So if you remember how to graph a line, you should remember how to graph an inequality. Oops. First thing we're going to do is try to put this in slope-intercept form. What's up? Oh. Do y'all remember what slope-intercept form is? Good. So pretty much we're trying to get y by itself in these. Okay? So how do we get y by itself? We need to get rid of what first? We could get rid of the negative 2 first because all of these are divisible by 2. Do y'all want to do that first? Alright, negative 2. If we do that, what's that going to give us right here? Negative 2x. What about here? Plus y. What about our inequality sign? Because we did what? Very good. Next one. And now what do we need to do to get y by itself? Yes, add the 2 what? X. Good. Alright, so we'll have y is less than or equal to, what do I need to write first? 2x minus 4. So that way it can be in slope-intercept form. Alright, what's my slope here? Good. So m equals 2. What's my y-intercept? Good. And if you remember how to graph lines, what do we graph first? The y-intercept, which is what? Negative 4. Good. So 1, 2, 3, 4. And then we go, what? Yes, up 2 over 1. Do it at least like 3 or 4 times. And I'll pass out rulers in a minute if anybody wants one. I do have those unpacked. The only thing with inequalities is it's either going to be a solid line or a dashed line. You have to keep that in mind. Why is this one solid? Yes. So it's got a bar underneath, which means it includes all the points on the line. Do y'all remember that? If not, let's write it down. So closed means it's a solid line if it has a bar underneath, and dashed if it has no bar underneath. So this one's solid, so go ahead and draw a solid line through those points. And now for inequalities, you have to check if it's going to be shaded above or below the line. And that's determined by our inequality, but not of the original when it's in slope-intercept form. It says below. So which side is below the line? The one without the origin. This is below the line, so that's where we'll shade. And some people have trouble like figuring out what's above and below the line, so I'm going to show you a way to check. Pick any point on the coordinate plane. 1, 2. That's right here. Draw a star on it. I'm going to plug 1, 2 into this formula, or you could do the original, either one. And if it doesn't work, if it's not true, then and this one won't be, then we won't shade it. So here we go. Plugging in y. So what's the y that Antonio picked? 2 is less than or equal to. The x he picked was 1. What's 2 times 1? Minus 4. Is 2 less than or equal to negative 2? No, that's why this region is not shaded. Any point in here that you pick and plug it in, it will work. It'll be a true statement. That's how you can check. Questions about that? Yes.
So looking at the equation, how are you supposed to know if it's above or below?
You just look at this. If it says below, like less than, you shade less than the line. If it's greater than, you shade greater than the line.
What if we use like
3, 4, 1, 2, 3, 1, 2, 3, 4, it would not work because it's not in the shaded region. Yes, then it would work, yes. Any other questions? The test point I always use is 0, 0 because it's so easy and to plug in, so yes.
I'm not getting around the problem at all, or greater than less than, so can I just plug in through?
Yeah, any point you want. So if it doesn't work, you wouldn't shade in that region, just like we did here. Alright, one more together. First, put it in slope-intercept form. So subtract 2x. Tell me how it would look then after that. Good. What else do we have to do to get y by itself? So tell me what that would be. Missing one thing. It has to be greater than, because we divided by what? Yes. But this right here, when we divide, can we divide 2 by 3? So we'll leave it as a fraction, but the two negatives will make it a positive. This one we have to divide by negative 3 as well, which would leave what? Yes. Before we graph, Colby, what's my y-intercept? Good. And Logan, what's my slope?
2 or 3.
And Darian, is this going to be a solid or dash line?
Dash.
Tell me how you know.
Because it's
Good. And Abigail, was shading above or below this line? Yes, because this says what right here? Greater than. So we would shade above the line or greater than the line. Alright, let's get to work. We graph what first? Yes, negative 2. And then go almost. Slope is rise over run. So first we would go up to which way 3? 1, 2, 3. Good. And it's dashed. So this is what I mean by dash. And above the line would be up here. So that's which way I'm going to shade. But I'm going to show you how to pick a test point just in case. One thing about dash lines. If I were to pick a dot on the dash line, like as this is my test point, do you think it would work? Alright. Amber, do you think if I plugged in negative 2, 0, 0, negative 2, this point right here, do you think it would work in my test point? You don't know? Alright. No, Victor, why?
It's not included in the values.
Good. The dash line makes it The points on the dash line are not included. That's why it's dashed. So you can't pick a test point on the line if it's dashed. Does that make sense? Alright. Michaela, pick any point you want to use. 1, 2. Okay. So we're using 1, 2. I'm going to plug it into this equation. So instead of y, I would put what? 2 is greater than 2/3 times 2, which is what? Let me write it down like this. 2 over 3 times 1, would be 2 is greater than 2/3 minus 2. And we really don't have to know what this is. It's going to be what kind of number right here? Not just a fraction, a negative. And is 2 greater than a negative number? Yes. That's why it's shaded in up here. Does that make sense? Okay. Questions about that? Alright, flip it over. Do do A on your own. It's already in slope-intercept form, so you can skip that part. Just find the y-intercept and slope and graph it. You don't want to get behind the comment. So this one probably is slope-intercept form. So which one? What's your slope on this one? The slopes always need to side it. Most obviously it's decided for their slope. So our slope here is what?
This is your line.
We don't have anything except for here, so our y-intercept's what? It's not there, it's what? You're gonna do what? It's not there, so. Yes. So the B is usually added to whatever it is, right? There's no number here, so our number is what? Right. Yes. Good job.
Is it right here? Okay. Yeah. Thank you.
Alright. Let's go over these two. Just one. Alright. Tell me, first of all, is it in slope-intercept form?
Yes.
How do you know that?
Because it's
Good. Alright, Justin, what's the slope here?
0.
That's good. The y-intercept is what?
0.
Good. If it's not there, it's going to be 0. The slope is always beside x. Is it dashed or solid?
Dash.
And tell me how you know.
Because.
Because
I forgot that part, but I know it's dash.
there's no what?
Oh, because there's no line.
Good. And above or below?
Above.
Because the inequality sign says what?
It's greater.
Good. So I would draw my y-intercept first. Question on the slope, like -3/4. Do I go down 3 or back 4? Does it matter? So what I'm asking is, should I make the 3 negative or the 4 negative? Or does it matter? It does not matter. So let me show you. You can go either down 3, 1, 2, 3, and positive 4, 1, 2, 3, 4. Or you can go up 3, 1, 2, 3, and back 4, 1, 2, 3, 4. It'll be on the same line. But both of them cannot be negative, because if it was, it'd be a what? Positive slope. Do y'all remember that goofy story I told y'all about me and Kelsey going skiing that one time? Okay. Also, if it's negative, you know it's got to be going downhill. Yeah, maybe it was roller coaster. I just tell a lot of stories. I get them confused. Alright, so it's dashed. It's shaded above, so is it going to include the point 1, 1? Yes. It's going to be all up here. Do I need to show y'all a test point, or are we good? Okay. The next one, go ahead and do on your own.
Chelsea, leave us.
Oh, I think she's been sick. She's just absent.
Wait, can you go back to?
Yes. Has anybody already graphed this one that I can use your paper? Pen first. Yes, the part A. It's just on what we did last week. Most of them finished. Anybody need more time on that other one? Alright, here is somebody's paper. and instead of coloring, she just drew like a triangle, so that's what that is. Is the y-intercept correct on her graph? Y-intercept? Yes, it's 0, 0. And then the slope was supposed to be negative 2 over 3, so she went down 2 over 3. So that's good. Is it supposed to be solid?
Yes.
Is it supposed to be shaded below? Yes, because this says less than. Everybody's good with graphing inequalities? Okay, now we're going to look at some constant inequalities. You pass that to Katie. So if you look at A and B, these are constant inequalities. This is y equals a certain number. Do y'all remember what kind of line this is? Horizontal. Good. And if it's x equals a number? Vertical. So what do I graph first on this one? What is my y-intercept? And what is my slope? Yes, this might be on your test on Friday. Hint, hint. Horizontal lines have a 0 slope every time. So I would graph negative 3 first, which is right here. And it'd be straight across. Is it going to be solid or dash?
Solid.
And above or below?
Below.
Very good. Go ahead and try B on your own. Make sure you list the slope, the y-intercept and the slope, because you'll have to do that on your test on Friday. Do the slope and y-intercept. Very good. Alright, sorry, we got to go over this one quickly. This is how the graph looks. Somebody tell me what's the slope of this one. Good. Undefined. Remember that vertical lines always have a slope of undefined. And what's the y-intercept? Good. Does not exist. Y-intercept does not exist, because where's our shading going to? The left or the right?
Right.
Good. And you can know this because it's pointing to the right. So does it ever cross the y-axis? No. Alright. You have a good day. Oh, don't leave your don't take your checkpoints. Turn them in the bin. Don't take your checkpoints.